Okay, so let's talk probability some more. We have a Venn diagram here showing two events, A and B, and I'm telling you that there are B things in the intersection. So the probability of A intersect B, that is probability of A and B, is equal to B out of A plus B plus C. We're going to pretend there's nothing that's not in one of these. So that's the probability of A and B. What's the probability of A? The probability of A would be A plus B over A plus B plus C. And the probability of B would be B plus C over A plus B plus C. Yeah? Okay, cool. Hopefully when I say yeah to this, you're agreeing with me. This makes complete sense. So what about this? Probability of A not intersect, but the probability of A union B. That would be probability of A or B. Okay, so let's think about what that would mean. It would be A plus B plus C, in this case, over A plus B plus C. And in this particular case, it's 1 because there's nothing outside there. But I want to think of this probability as this sort of stuff. A or B, you might think, well, that's going to be the probability of A plus the probability of B. I think when I say or, that means add. So what would this be? We'd have A plus B over A plus B plus C plus B plus C over A plus B plus C. And that would be A plus 2B plus C over the total. And that's not what we said up there. There's too many B's. What we need to do is we need to subtract, in order to get these two things to be the same, there and there, we need to subtract B over the total. And that's the probability of A intersect B. So here is a probability rule for us. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A intersect B. And we have to subtract that because the B got counted in both the probability of A and the probability of B. The intersection got counted twice when we add these two together. Okay, well that's great. But, you know, sometimes it's true that the probability of A union B is equal to the probability of A plus the probability of B. We can use this when A and B are what we call mutually exclusive. But you're saying, wait a minute, we just showed that that can't be true. That this sum isn't true because we count the intersection twice. We just figured out that this is equal to probability of A plus probability of B minus the probability of A intersect B. Well, yeah, that's true, but what if there's no intersection? What if these circles in our Venn diagram look like that? And there is no intersection. That's what mutually exclusive means. It means there is no overlap. It means probability of A intersect B equals 0. So the definition of mutually exclusive events, A and B are mutually exclusive if the probability of A intersect B is equal to 0. That means that they don't overlap. They don't share these two traits. There's no event that is in both A and B at the same time. And if they're mutually exclusive, that's going to be true. So, example time. I pick a pen at random from a box. I have this big box of pens, lots of different colors. I know the probability of picking a red pen is 1/5. 1/5 of the pens in there are red. I know that 3/7 of the pen in this box are green, so the probability of picking a green pen is 3/7. I want to know what's the probability of drawing neither a red pen nor a green pen. In other words, drawing something. So what I'm looking for is the probability of the complement of red or green. I don't want red or green. So I want the complement of that. So let's start, before I find this, that's just going to be 1 minus probability of red union green. So we need to find this. That's the first thing we got to do. So probability of red union green well, picking a red pen, I don't have any of those magical pens that are both colors at once. So picking a red pen, picking a green pen, those are mutually exclusive events. So this is equal to the probability of red plus the probability of R. So 1/5 plus 3/7 is 22 out of 35. So the probability of getting not one of those colors would be 1 minus that, or 13 out of 35. So when I'm talking about mutually exclusive events, take this pen example. A red pen and a green pen are mutually exclusive events because I can't pick a pen that are both colors at the same time. That's what we're talking about. If I had a magical pen that had both colors in it at the same time, then yeah, they're not mutually exclusive. But there is nothing that fits with both of these categories. That's it.